Hi there, welcome back here, guys. In this lecture, we have been sending transactions to our account address where we have been specifying function signature in a transaction as a transaction data, and we have sent 3 Ether. In this lecture, I'll continue. I will show you just very interesting thing. Will be very quick lecture. Please open your tabs here and let's search here. But we'll go to Remix. Okay, so let's go to Remix Ethereum IDE, so we can get their contract and we can compile it. Okay, I just want to show one instructions, very interesting things here. Since we have added function add funds, when we will compile our code, there should be this hexadecimal 4 bytes of our function signature, and it's not loading for me for some reason. Okay, maybe there is, okay, now, perfect. So let's go to contracts. Bow doesn't really matter, and I have already my function here. So just go ahead, get your function, copy it, paste it here, please. Go to left side, click here on the sign of the Solidity sign and Solidity compiler, compile ballot. This will create your bytecode. Let's go to compilation details down here, and we'll go to assembly. This will get you more readable instructions. These instructions up here, this code init instructions. We have been already talking about what this does. It's basically copying a code. Okay, so this push 80, push 40, as I told you, that's basically you see it almost in every smart contract, MS Store to store this and to memory and so on. But what we are interested in here is our data, which is this code that will be executed when you will make a transaction to a smart contract. So what is interesting when we are sending a transaction data here, I will not go through all of this here. I will go through these interesting parts. The bytecode here is saying call data load. What this will do, this will push onto the stack. This call data load will push on the stack your data of your function signature. Okay, so what you are sending here, call data load here will be this data. This will be pushed in a stack. Okay, so in this structure of the stack, you will push here this function signature. Okay. Okay, so this is pushed from a call data load. Then there are some bytes pushed on the stack. E0, this should be 28 bytes. When you will transfer from hexadecimal to binary, this should be 28 bytes. And SHR is a shift right. So this is a byte shift right, bit shift to the right side. What this basically will do, it will push some bytes onto the stack and will move. It will move the bytes in the call data call data load. This basically is just this. What this basically is saying here is to get the data from the transaction and compare them with this signature, and this is the signature of our function. Okay, I don't want to complicate here things. When you will compare here, this is a signature of your function we have found here. That's our function signature, right? So one more time, this will load the data from a transaction. This will be our function. This here, it will be our function. We'll do some operation and we'll compare it with this function here. And if it is our function that's in a call data load, so if it's this function, it will basically compare. You can see here equal. We'll compare the call data load and with our function. Then we'll basically push to the other instruction. So we'll jump to the other instruction here, and we'll do some other operations. Basically, we're just jumping around and verifying a couple of things, reverting if something is wrong. But that's basically, we don't have much functionality in our advanced. It's basically just an empty function, so not much is happening here. But basically, call data load the instruction from a data of a transaction, which is our function, and do some bit shift operation, and then compare this with this function here. If we would have a more function here, we would not have only add funds and so only add funds, but we would have multiple functions. Then we would have here multiple push. Then we would have here multiple push operations. Okay, so if we would have more functions, I'll show you. Then we would have here also multiple push operations. So we would have here push some other function, push the other function. So for all of the functions, all of the function signature will be pushed onto the stack, and here we'll be comparing them. So we can imagine this as a switch case. Okay, so when we will load the data function signature, and we are comparing with all the functions that we have available. And if we found the function, we'll just jump into the function code in this byte format. So you can imagine it as a switch case. Okay, so you can have a switch. All right, you will load the data, call data load. Okay, this can be some function, 0x to 3 to 3 to 3 to 3, doesn't really matter. And then you have a bunch of cases. Okay, so in the case of 0x, blah, 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 and you have a bunch of cases. That's basically is stated in a bytecode. Okay, and for all the functions you will create, you will have this. It's called jumping table. So you have a get a load data and then just jump into particular bytecode if they are matching. Okay, so it will check. The data load will match this. Okay, it's not matching. Nothing will happen. Nothing will happen. It match this. Yeah. Then jump into the function code and execute instructions. Okay, so I just want to show you this so you have at least basic idea how this is done. Okay, guys, so now we can continue in the next lecture. We'll be creating more functions and we'll be now more and more focusing on functional part of our code, but still we'll be talking a lot about Ethereum and the technologies related to it. So guys, I have to see you in the next lecture. Cheers.